So in this next section, we're going to keep with our idea of figuring out how many different ways we can do something, but we don't want to have to list them all out. We want to have a quicker way to get that done. So the next two sections are really going to go over quicker ways to do it than listing them out like we saw in 10.1. So this is our fundamental counting principle. Is this first one that we're going to go over in 10.2. So the fundamental counting principle is based off this multiplication rule. And for all of these that we're going to be doing in 10.2 and in 10.3, we are going to be multiplying. I don't want to see any additions, signs whatsoever. That's something that comes up sometimes. I don't know where it comes from. We're not adding. You're not going to see me adding things together pretty much at all. So basically what this says is we're going to be maybe doing something like flipping a coin this first problem, or we might be having choices on choosing a class to take or something like that. And we're going to do it multiple times, and we're going to multiply the number of options together each time. So we've got our multiplication here, and you can use as many multiplication terms as you want. That's why we have the dot, dot, dot there. It might be 2, 3, 4. We'll get to some that have like 9 different choices in there. So as many as you might need. So that's why we've got the dot, dot, dot and the K down there in the bottom, because that just says go up as high as you need. So we've actually seen this first example before, but we're going to come back to it. I'm not going to actually list out the ways that I can actually flip a coin. I just want to know how many. It didn't ask me to list. So when there's a coin, there are 2 choices for the first coin. And I'm always going to be writing down how many choices or options there might be. For the next time I flip a coin, there are 2 choices again, heads or tails. And then the third time, there are 2 choices. Look that I did not include a 3 in the problem. The 3 tells me how many times I'm multiplying. Some people really want to see the 3. You could write this as 2 cubed. Those are going to be the same thing. They're both going to give you the answer of 8, which is the answer for this problem, and we've actually seen that before. Keeping with this same idea of multiplying together my choices, in the next example, I get to choose between 7 flavors of ice cream and 5 toppings. So I have 7 choices for my flavors, 5 choices for my toppings. I'm going to multiply those together and get 35 as my answer. As simple as that. You do want to make sure to include your work on these. Once we get into 10.3, they're going to be problems that seem very similar, but they're different. There's one way to work them. So you might get them mixed up. It really helps if I see work so I can give partial credit. If you just have a wrong answer down there, I don't know which way what you might have typed in to get that wrong answer. So definitely take the time to show the work. It doesn't take very long to write 7 times 5 out on your paper. All right, this next one's a little bit trickier. This one we're going to have license plates. We're going to have 3 letters and then 3 numbers. So I've got 6 total things here. And I'm always going to be multiplying because this is the multiplication rule. The first 3 are letters. The second 3 are numbers. There are 26 letters in the alphabet. So there are 26 letters. There are 10 numbers. You can remember this because you have your calculator in front of you. Count up the digits on there. 0 through 9. You do have to include 0. There are 10 digits. We're going to multiply those together. And this is going to give me a really big answer. Let me get it all the way written out. 17,576,000. So a whole bunch of answers there. And our answers can get really, really big. They might get so big in some of the later videos and sections that we have to use scientific notation. We'll get there, but do expect big answers. That's kind of the name of the game with these guys. All right, this last example on this page is probably the trickiest. If you can follow this one, then you're really probably good to go on this 10.2. I think it's the trickiest one. So we're going to construct a 4-digit number. So that means we have 1, 2, 3, 4 digits. We're in the thousands place. But we can only use the numbers 7, 8, and 9. So for instance, the number 9,887. That's a 4-digit number only using those 3 digits that I allowed you to use, 8, 7, and 9. So for each one of the place values, the thousands place, the hundreds place, the tens place, and the ones place, we each have 3 choices. And of course we're multiplying because it's the multiplication rule. So I've got 3 times 3 times 3 times 3. If you really want to see that 4, you can write 3 to the 4th. Either way you type it in your calculator, you're going to get 81. Now for part B, I'm going to keep with my idea again of those 4 digits, thousands, hundreds, tens, and ones. But this time I've got some stipulations. It has to be less than 8,000. So if you're less than 8,000, you only have one choice. In this thousands place, you have to start with the number 7. So there's one choice. You had to choose the number 7. Don't put 7 there because they're not 7 choices. The 1 stands for how many choices there are. There's only the one choice. It has to be the number 7. To be odd means that the ones place has to be the number 7 or 9. If it ends at 8, it's an even number. So you have 2 choices for the last number. Now, I don't care what you go on in the middle. The middle has nothing to do with being less than 8,000 or odd. So you have all 3 choices. You could be 7, 8, or 9. We're going to multiply those together to get my final answer of 18.